For our next topic, we're going to look at mass percent and mole ratios. So what is mass percent? Mass percent is the percent of the total mass of a molecule that is due to the presence of a particular element. So what that means is that the mass percent of an element is the mass of the element in 1 mole of compound divided by the mass of 1 mole of that compound. And of course, that value is going to give us a decimal. So to turn it into a percent, we multiply that by 100. So let's do an example. So we're going to use the same molecule that we looked at in the last video, the C9H8O4. This is the active ingredient in aspirin. And we want to find the mass percent of carbon in C9H8O4. So if you remember from the last video, we found that in this molecule, we have 108.09 grams of carbon, 8.08 grams of hydrogen, and 64.00 grams of oxygen. And this is all in 1 mole of C9H8O4. Remember, that's the individual atomic masses of each atom combined to form the molar mass of the compound, which remember was 180.17 grams per mole. So if we want to find the mass percent of carbon in this sample, then we're going to take the mass of the carbon, which is 108.09 grams, divided by the mass of 1 mole of the entire compound, which is 180.17 grams, and that's going to be equal to 0.59993 times 100 to turn it to a percent. And that is going to give us 59.993%. So that means that 59.993% of this sample is made up of carbon. So that's how you find the mass percent of a particular atom in a molecule. But sometimes we don't want to use mass or mass percent. Sometimes we want to look at the moles directly. And sometimes what this is going to allow us to do is figure out how many of a particular type of molecule or atom there is in a molecule. So again, let's look at C9H8O4. So we can see here that in every 1 mole of this molecule, we have 9 moles of carbon. So if we were to break this molecule up into its individual atoms, we would end up with 9 moles of carbon. So that allows us to write 9 moles of carbon will be present for every 1 mole of C9H8O4. C9H8O4. And what that allows us to do is it allows us to calculate the amount of individual carbon in this molecule. So we're going to do that in this example problem. How many grams of carbon are there in 4.85 grams of C9H8O4? So we'll start our dimensional analysis with 4.85 grams of C9H8O4. And this is one of those times when it's important to write out the full molecule because we're going to have different substances in our calculations, and we don't want to mix them up. So now we know that we want to get rid of C9H8O4, so we're going to put that on the bottom. Then specifically grams of C9H8O4. And the only thing we can really convert to at this point is moles of C9H8O4. We just don't have the information to convert to anything else, but what we can do is we can use the molar mass to convert to moles. So remember from this previous problem, our molar mass is 180.17 grams per mole. That's for the entire molecule. 180.17 grams of C9H8O4 for every 1 mole of C9H8O4. So this is really key because since we got to 1 mole of C9H8O4, we can use this relationship that we highlighted above, the 9 moles of carbon, because now that we're at moles of carbon, we can use the molar mass of carbon itself to find how many grams of carbon we have. So for every 1 mole of carbon, we have 12.01 grams of carbon. Let's check our units. So grams of C9H8O4 cancels with grams of C9H8O4. Same thing with moles and moles. Moles of carbon with moles of carbon. And then we are left with grams of carbon in the top right corner. And that's what we were trying to find. So we probably set this up correctly since everything else cancels out. So I'll give you a moment to solve this on your calculator. You can pause the video to solve. And this answer should be 2.91 grams of carbon. So for every 4.85 grams of C9H8O4, 2.91 grams of that is carbon. And based on what we know from this previous section over here, about 60% of that sample is made of carbon. And 2.91 looks to be, even just looking at the number, looks to be about 60% of 4.85 grams of C9H8O4. So that's a way you can kind of check your work and see, okay, well, it looks like my answer to this problem is probably reasonable, so I probably got the right answer.